Again, this has got a lot of different things in here, and it puts a lot of the different pieces together. But this is the fed state, right? In a high carbohydrate diet, we can make new lipids out of our carbohydrates, and we're going to talk about how that happens. We can esterify our free fatty acids to form triacylglycerols. Oh, this is page 359. And then we're going to make VLDL synthesis, and we're going to secrete it, and we'll talk about that in chapter 17. But VLDL synthesis is how we send those lipids out for use in other places, right? We send the lipids out to the adipose. We send the lipids out to every extrahepatic tissue. So, this box plus this box is what we did last time and this time, okay? How do we get them out of the small intestine? Where do they go? How do they go to the liver, right? And what happens to them in the liver? So, before I go any further, does everybody understand this general concept in the fed state? Because this is important. Now we're going to do the other half of this box, which is the fasting state. So I'll go put it on the other side of the board. Okay. Okay, so insulin is lower, glucagon is higher. Okay, so we're assuming no carbohydrates for energy present, right? So what are we going to do? We're going to use fatty acids for energy, which means we're going to beta oxidize them. And the beta oxidation has to do with, you know how we talked about the alpha carbon? They call it beta oxidation because we're working at the beta carbon, which is the carbon next to the alpha carbon. And we're going to shorthand a lot of the specific mechanisms. Oops, sorry. I'm going to highlight a couple of things, including acetyl-CoA and malonyl-CoA, because those are, if you can pick those molecules out, you can follow the process, but we're not learning a whole lot of pathways. We're not going to do, okay, how do we oxidize a 16 carbon? I'm not going to make you go, okay, 7 more times we're going to do this enzyme, and 3 more times we're going to do this. I want you to really understand this. Lower amount of insulin, higher amount of glucagon. We don't have a lot of carbohydrate for energy. We're going to use fatty acids for energy. So we talked a little bit, we can use those amino acids, especially the ones that are gluconeogenic, but that comes at a really big cost. We need our amino acids to do other things. No amino acids, no protein. So we have a huge amount of free fatty acid storage. We store it in the liver, we store some in the muscle, and we store a lot of it in our adipose tissue. So that's what we go to. We go oxidize these. We liberate them from the adipose, we bring them back to the liver, and then we can use them for energy. Or, now, are we taking a lot in from the small intestine if it's fasting? No, we're really not. You can process, there's some left over, right? There's always some residual amount of fatty acids hanging out in the enterocyte, and you can make a couple chylomicrons, you can make some VLDL, then you can get them out of there. But for the vast majority of the fatty acids in the fasting state, they're coming from storage. So,
and if this was a final essay question, would you want us to add more information from the book, or would this be?
so I wouldn't give this alone as an essay question.
Oh no, I know. But
Right. Okay. So there's let's see. I could use this information, and now we're going to talk about specifically how we regulate that. So if you understand these base state in these two conditions, now we're going to talk about how we make fatty acids, how we oxidize fatty acids, and even more important in my own brain, how we regulate the amount that we're making versus the amount that we're breaking down. There are a lot of different mechanisms, unlike carbohydrate and protein, where a lot of these things occur in the same space. In fatty acids, we separate the making from the breaking down. We keep them separate, and their products and their intermediates do a lot of allosteric and competitive inhibition to make sure that we're not doing too much of one versus the other. Because as we